All right, so we're going to be defining rigid transformations. So what I did was I kind of just put a couple pictures of what rigid transformations look like. So if we recall, they are your reflections, your translations, and your rotations. Rotation. All right, so we can see kind of the translations. One's going to one side over here. Okay, again, translation right here. Little rotate, so one's going one direction. Notice that these two are reflections. So again, we can kind of see the difference between the two. Okay, so you're going to be looking at your resource page, and I want you to look at this first problem. So rotations on a grid. So consider about what you know about rotations, a movement that turns a shape around a point, because again, this would be called the point of rotation, right? So point of rotation, okay? And notice that some of these points are not attached, some of these points are attached, and some of them are in the middle of this, okay? Remember, if you're going to go this direction, this means counterclockwise. Okay, and then if you see this direction, this means clockwise. Oops, clockwise. And again, 90 degrees. If we have difficulty with it, remember that you're going to make an addition sign on your patty paper. And then say I have a blue dot right up at the top, and I want to rotate this 90 degrees clockwise, this direction. That means that your new image would look like this. Right, so it would turn, the blue dot would turn to be over here. So, so notice that it says, does it make a difference if the rotation is clockwise or counterclockwise? So will you still get the information? So 180, again, would be 2 of the 90 degrees, so that dot would be down here. 360 again goes all the way around. 270 again would be 3 rotations all the way around. So again, pay attention to where you have it. Use your patty paper to help graph. And then pause the video so that way you can come back and see what your answers are. Okay, so if we paused our video, we should have all 8 of these graphs done. So this is what your graph should look like. Again, if you haven't paused it, go ahead, pause it, come back to this. But this is what the graphs look like, right? So notice 180s clockwise versus 180s counterclockwise does not make a difference, which is nice. Notice 90 degrees clockwise versus 90 degrees counterclockwise does make a difference, okay? But ones that doesn't make a difference, right, would be, right, this guy right here, E and D. So notice that if I go 90 degrees one direction, right, and then I go a 270 in another direction, right, you're still going to end up at the same point. So that's really important about those types of rotations. That'll come in handy later on. Okay, other things to be aware is notice that on F, G, and H, it almost looks like you did not draw anything new, okay? Because the rotation actually kept the image exactly where you need it to be. 360, you'll always land in the same spot, but notice that for 180 or even 90 degrees, especially if it's in the middle, sometimes your image is not going to change. And that's going to be important when we talk about something known as symmetry. So again, planting the seed for later on. Okay, so now what I want us to do is I want us to plot these points. So I want you to pause the video right here, and I want you to try to answer A, B, C, D, and then we'll talk about E when we come back from the paused video. So again, pause the video right now and walk through your steps on your graph paper. Remember, this is A prime and this is B prime, and we use those when we're talking about our images. So go ahead, pause the video now. Okay, so if we're coming back from a paused video, all right, let's go ahead and answer these questions. So on graph paper, we're going to plot these points. So to the best of my ability, I'm going to plot these points. So 4, 1, so there we go. I'm going to call this A. And then 2, 5, I'll call this B. Okay, so we're going to go ahead and I can connect the points to the origin I don't think, oh, I'm kind of ahead of myself. I'm kind of doing part B, so I'll hold off on that for just a hot second. Okay, so let's continue. Then we use our tracing paper to rotate counterclockwise. So if we rotate counterclockwise, right, that would be this direction, right? We're going backwards. Okay, what we should have seen is that the point A now is at the point -1 and 4. So this is now A prime, right? So again, -1, 4. And our B value should now be at -5, 2. So again, B prime, -5, comma 2. Okay, and that's going to be very important, right? So notice that, so again, 2, 5, and 4, 1. Okay, so next thing what we want to do, so draw line segments to O. So O is the origin. So again, this is O right here. So let's go ahead and draw those now to the best of my ability, right? Hopefully you guys used a straight edge. Here we go. So that is A to O, and then B to O. And then let's go ahead and connect, let's do it in red, sorry. So let's now connect those together and those together right there. Okay, so what I want you to do, right, if you have not already done it, using your tracing paper, compare the lengths and angles formed. So again, what you're going to do is you're going to trace this image, and then you're going to rotate, and you're going to put it exactly onto this image. What you should notice is that B and B prime are equal, right? You should also know in length, right, in our length. So how we can actually write this a little bit clearer is we can actually use this as, here's O, we can actually say this. We can say that O to A is equal to O to prime, and then we can say O to B is equal to O to B prime. So again, it just is a line segment. We will deal with this more with our geometry section, so later on this year. What you should also notice is that this angle right here is the same angle as this. Okay, so what I can say is I can say the measure of this angle, and I don't really know, when I say O, I don't know if I'm talking about this angle or this angle, so we actually use 3 letters. Again, we will discuss this a little bit more when we get to geometry. But what this is basically saying is that our angle O is equal, right? So we're basically saying this angle and this angle are equal to each other. Okay, so if this was, say, 20 degrees, this is also 20 degrees. M, just FYI, stands, and this M right here stands for the word measure. So when we talk about the measurement of something. Okay, now, this is also really, really important. What we should also be discussing is we want to know this information, right? So now part C, we want to predict A to O to A prime, right? So I'm going to go ahead and I'm just going to take off this little piece right here to the best of my ability. Okay, and so I want to know this guy from here to here. What is that? Okay, and what you should have realized is that that angle measurement is actually 90 degrees because the line segment A to O is slope is going up 1 and over 4. So 1/4. And then O to A prime, right? You're starting here, you're going down 4, right? And then over 1. So notice that they are opposites, positive, negative, and notice that they are reciprocals. So again, we're seeing kind of those things that we talked about with perpendicular slopes. We can now see those in reflections. And that's actually how we're going to truly know that something is reflected properly. Okay, so moving on to D. So why does it make sense that for all points P on the graph of rotation about this, they're always going to be equal measurements? Basically what this means is that the rotation preserves the distance around all the points, right? So let me write that down. So a rotation, I might run out of room here. preserves, oops, I spelled preserves wrong. I started to spell it wrong. So preserves the distance between, this is the symbol for between, B and W, all points and the point of rotation. Okay, so again, that's kind of what they were saying, and that's really what's happening. Happening here, right? Using the tracing paper to help us explain where rotation does not change any of the angles or the length. Again, it preserves. So I want you to make sure that you do have this written down in your notes. When measures do not change, we call that preserved, as in the angle measures are preserved. So that's the most important thing. So I don't want to cross that off. I want to make sure that we have that underlined. So the measures do not change, right? They are known as preserved. Okay. So let's look at this problem. Okay, so we've already seen this problem a little bit before, right? So again, we can kind of find that diagram on 3.1.4. And so I want to again discuss what's happening between P and P prime, Q and Q prime, R and R prime. What's the relationship between these three dashed line segments? So what we got last time we were kind of doing this, again, I just want to make sure that we have a clear definition. So if I'm going to R, right? So notice that I'm going to go down 1, and then actually if I'm going to go all the way to R, I'm going to go down 2, 1, 2, so now -2, and I'm going to go over 1, 2, 3, 4. Okay, so if I drew, right, a dashed line, I know that R to R prime slope would be -1/2. So let's test it out. Let's see if that's actually true for the other ones, which we kind of already discussed. So if I go down 1 over 2, right, down 1 over 2, I hit my line of reflection. And then again, if I go down 1 and over 2, notice that again I hit my Q. So notice that these all have still the slope of -1. So R prime, Q prime, again, the slope is -1/2. And then again, this one's a little bit more difficult to see. So if I go down 1, and then I go over 1, 2, right? So down 1 over 2, so 1, 2. Again, the slope is -1/2. So P to P prime slope is -1/2. So notice if this is -1/2, this is -1/2, this is -1/2, what relationship do we have? Well, all of these lines are parallel, right? They all have the same slope. So that's kind of exciting. Okay, so the other thing I want to point out here is this. What do you notice about R prime and the relationship between the line of reflection? So go ahead and find that slope of this line of reflection. I'm going to go ahead and erase this now for just a second. You can always draw this back in. Oh, my picture's gone. Oh, and it's back. Okay, so if I notice this, right, I'm going to go over 1, so 1, and notice I go up 2. So my line, so I think they called it line L. Notice that my line L's slope is 2 over 1. So what do you notice about line L's slope is that they are perpendicular. So that's exciting, right? So when we reflect it over these points, they become perpendicular, which is kind of, again, what we saw here, 90 degrees, which means this line and this line are perpendicular fit, right? So very, very exciting stuff. All right, so in the next video, you guys are going to, this is the first problem that we're going to start with in the next video. So go ahead and answer this question, and then when you're ready for the answer, click on part 2.